Hello everyone. Today I would like to show you a very slick way to derive the unit circle. The only background knowledge that you'll need to follow this video is the Pythagorean Theorem and SOHCAHTOA. So to derive the entire unit circle, we actually only need to figure out two of the points that are on the unit circle here. These 2 points are right here and here. So one of them is with a 45, 45, 90 triangle, and that's drawn over here on the left. And then another one comes from this point, which creates a 30, 60, 90 triangle. So let's start with the 45, 45, 90 triangle, because that should be the easier of the two cases. So notice one thing that's nice, and that's that because it's a 45, 45, 90 triangle, two of the sides are actually the same because they're both across from 45-degree angles. So that's nice. So I indicated that here with these lines. And the other thing that you can notice, the other thing that we should recognize is we're dealing with a unit circle here. And with the unit circle, we know that the radius has a length of 1. So in this picture, what we'll do is we'll draw in 1 as our length. And because we don't know what the other two sides are, we'll just call them x. Okay, so now, as said before, we'll need the Pythagorean theorem. So applying that in this instance, we take the two shorter sides. The two shorter sides are just x and x here. We take the two shorter sides. So the Pythagorean theorem tells you that a squared plus b squared is c squared, or the two shorter sides squared and then added together gives you the longest side squared. So working that out here in this specific instance, the two shorter sides are x, so we would have x squared plus x squared is 1 squared. With a little bit of simplification, x squared plus x squared is 2x squared. 1 squared is just 1. And next, because these are connected through multiplication, we have to divide by 2. Dividing by 2 on both sides gives us that x squared is 1/2. And lastly, because we have a square, to solve for x, the last thing we need to do is to take the square root of both sides. So upon doing that, we get that x is the square root of 1/2, which is the same thing as the square root of 1 over the square root of 2, which is just the same thing as 1 over square root of 2, because the square root of 1 is 1. And lastly, what some authors like to do is to rationalize the denominator. And that essentially means get rid of any radicals that are in the bottom. To achieve this, to get rid of the radical down here, we can multiply by the square root of 2 over 2, over the square root of 2, I mean. And when you do this, what happens is on the top you'll just get square root of 2, and on the bottom you'll just get 2. Notice root 2 times root 2 is 2. So this tells us that in this 45, 45, 90 triangle that we started with, we always know that if we're starting with the unit radius, the radius of 1, that the other shorter side lengths will be square root of 2 over 2. And just as like kind of a numerical approximation of this, this is about 0.70 something. I'm blanking on the exact digits, but feel free to use a calculator to check what that would be. All right, so next what we should do is we should probably just plot that point up above on our circle. So we got that root 2 over 2 is the x-coordinate, and it's the y-coordinate. It's the base of the triangle here, and it's the height. So that means that in this picture, this is our 45, 45, 90 triangle here. It means that the x-coordinate is root 2 over 2. And so is the y-coordinate. Okay, so now we've worked out one of the two pieces that we need to derive the entire unit circle. Now we're on to the next one. The next one is a 30, 60, 90 triangle. So here it's a little bit trickier. It requires a tiny bit of ingenuity to figure this out. So here's what we'll do. We'll start with an equilateral triangle. I'm going to draw this as best as I can, kind of on the fly here. Don't judge the angles too much. It's just not drawn to scale, as they say. So this is a 60-degree angle. And just to indicate that all of them, I'll just make these little humps. These are all 60-degree angles. So here, what we'll do is we'll do something similar. We'll decide off the bat, because we're working with the unit circle, that the radius of, or rather the side length of any side of this equilateral triangle is 1. And it's equilateral, so that means they're all the same. And now what we're going to do is we're going to take this triangle. I'll draw it over here just a little bit bigger. We're going to take that triangle and we're going to chop it right down the middle like this. All right, we know that all of these lengths are 1, but because, this whole length right here is 1, but because we're chopping this directly down the middle, we actually have that the base right here is 1/2. It's exactly half of 1. 1/2. All right. Now this is nice, because what we started with is these 60-degree angles, and I chopped it in half. So that means that up here I now have a 30-degree angle. I know this is still a right angle because it's dropped straight down. And I see here that this exactly is what we need. This is the 30, 60, 90 case. So this equilateral triangle situation split down the middle perfectly corresponds to what we need to figure out. So bringing it all together now, though, we see that the thing that we're missing in this triangle, if we're just focusing on this right triangle here in the middle, the one thing that we're missing is we're missing the height. We don't know the height, so I'm just going to call it h for now. H for height. Now let's determine what that is. So we've already figured out one part of this unit circle up here. We actually know, for a fact. Well, actually, I'll come back to that. Anyway, though, so we can use the same exact thing that we used on the left side here, which was the Pythagorean theorem. So let's go ahead and try that now. We see that one of the side lengths has a length of 1/2. That's one of the short sides. So we take 1/2 squared. We take the other short side, which is h here, and we square it. We get h squared. And we know that's going to add up to 1 squared. And again, 1 squared is just 1. And 1/2 squared is 1/4. H squared is just h squared. And we're going to solve for h. So with a tiny bit more algebra, we can just subtract 1/4 from both sides. So subtracting 1/4 here and here. All right, now this leaves us with h squared is 1 minus 1/4. Well, if you have 1 and you take 1/4 away, you're left with 3/4. And if we take the square root of both sides, similar to what we did over here, we get that h is the square root of 3 over the square root of 4, but the square root of 4 is just 2. So we end up getting h is the square root of 3 over 2. So that is the height of this triangle right here. In other words, that is the side length that will be across from a 60-degree angle in a 30, 60, 90 triangle. And 1/2 is the side length that's across from a 30-degree angle. So bringing this all together, let's come back up to our unit circle. We had, in this situation, we knew that across from a 30-degree angle was 1/2. So that means that with this triangle here, this height, or this y-coordinate rather, is 1/2. And the base we got was, coming down, was the square root of 3/2. So I'm going to fill that in as well. So square root of 3/2 there. All right. Well, with this, with these 2 points, we've derived the point right here. This point is root 3/2, comma 1/2. So we've derived these 2 points, and with any other angle that you want, we can get the other coordinate values. So anywhere else on this unit circle, maybe in another video I'll show you how to extend this to give you every single value on the unit circle. But I give it to you as a challenge to try to see how you could use a little bit of transformations, some geometry to determine, say, like what, say, the 60-degree angle here that gets formed, for example. Let's see if you could come up with what the height of this would be and what the base of this would be. Be a good exercise. But anyway, yeah, that's just a little look at how we could derive the unit circle from scratch. And in the future, we will actually fill out the whole circle. But I do leave it as a challenge for you to consider how you would fill it out. Anyway, that's it for this video. So if you have any questions, feel free to drop them in the comment section, and hopefully we can get them answered for you. All right. Have a nice day.